Okay, so we have here our returns for stock A, which is AT&T, and stock B, which we'll call Burger King. Okay. And we know, of course, that to get these returns, we have looked at the prices, historical prices, and historical dividends, and calculated the returns here. So now we have our sample returns. We know from our returns we can get the expected return, the standard deviation. But as it turns out that when you start to deal with portfolios, remember this, you need something else, not just the expected returns and standard deviation, but you also need these guys here, the covariance. So this standard deviation is the square root of the variance. Okay. We need the covariance, and we also need a correlation. Actually, you need only one of these because they give you the same information, right? And so that's what we have here: our expected return, standard deviation, our correlation, and our covariance. So let's go ahead and calculate that for. You've done it already? Are you planning to? Give it a try.
We just started.
So let's go ahead and calculate. We know for the expected return, we're going to use the average. For the standard deviation, we're going to use the standard deviation function. For covariance and for correlation, once you start typing in covariance, it'll give you a choice. For correlation, once you start typing in correlation, it'll give you a choice. I picked SVDEV-S, the sample standard deviation. Yep. So. Correlation is always a correlation between two variables. And for covariance, I'll pick again the sample covariance. And again, it's between two columns. Wow, that is a seriously crazy correlation. Seriously crazy. So this again is this is the theory now we're working with here. If you've taken 4407, 4409, you know this theory already. Okay, so Sarah, I know, has taken 4407, so she's good. So is good. Val, you're in trouble. So the theory essentially says if you have several stocks and you put them together in a portfolio, once you know their expected returns, their standard deviations, and their covariances or their correlations, then you can find the expected return of your portfolio. So the expected return of the portfolio, and so we'll say here for stock A and B, the expected return here is equal to WA RA. Let me see the notation that's used here. Okay, that's the expected return of stock A plus this WB expected return. And so we need, of course, to know what the weights are. The weights are what percent of your money is in stock A and what percent, okay, what proportion of the money, what proportion of the portfolio's total value is in stock B. So we're going to adjust the weights. We'll say, for instance, if we put 100% of the money in A and 0 in B, so all the portfolio is in A, okay, then we get essentially what the portfolio's expected return is. So let's move this aside, by the way. Let's shift this here and just add in one more column here and say portfolio's expected return. That's the expected return, and over here then is our standard deviation. Okay. So we can, of course, do what we just did. Okay. We can go to here and say this times our expected return for stock A plus this times the expected return for stock B. And that gives us the portfolio's expected return. Fair enough? I mean, we know, of course, since we want to copy this formula all the way down, we don't want to keep typing it in. We need to absolute reference these two guys, but allow this guy to change. So we'll allow our weights to change, but we'll have where the expected returns are the absolute referenced. So let's just absolute reference this guy here and this guy here. So if you have 100% in A, and if you have 100% in A, then your expected return is 80 and standard deviation is standard deviation. So that's fine, okay? What about this here, the portfolio's standard deviation here? Now, the formula is given here, and the formula is kind of tricky. Okay? Again, for those of you in 4407, you've seen this before, or 4409. Okay? We know then that the variance of the portfolio is going to be equal to WA squared, okay? Variance of A is WB squared, variance of A, plus 2 WA WB. The correlation between A and B, this A and this B. So you can see this formula looks a little bit messy. And luckily with Excel, we don't have to type in the formula. With Excel, we can simply use then a function in Excel called the matrix multiplication formula. So we want to do that sort of just now. But let's first speak about correlation, just to remind ourselves what about this guy here. Let's remind ourselves about this guy. About this guy. So we'll recall essentially from our statistics days, okay, the covariance between A and B is equal then to the correlation between A and B, standard deviation of A, standard deviation. So we could replace all of this by covariance, okay? All of this by covariance. But this is useful, of course, because the correlation minus 1, okay, plus 1. And that's what we want to say here. Okay. There is no limit to covariance, but the correlation, okay, has a limit. It's bounded. When it's minus 1, it's perfectly negatively correlated. When it's plus 1, it's perfectly positively correlated. So what does the correlation tell you? Takashi, you've taken 40/407, so you know. What does the correlation tell you? Ask. Then what does the correlation tell you? What information does it give you? What information does the correlation give you? How the two stocks are related. That is, we're seeing here that stock A, its returns are all over the place, from 10% to -1 to 14% and so on. And stock B, they're kind of all over the place. But are they related? Do they move together in some way? Are they systematically related in some way? The correlation tells you that. Okay? If the correlation is +1, it means they move perfectly together in lockstep. Right? If A goes up by 1%, B goes up by 1%, and down by 1%, and so on. If it's -1, they are perfectly negatively correlated. They move in opposite directions as mirror images. And if it's somewhere in between, then they don't move perfectly together, okay? But they kind of move together, unless the correlation is 0. If the correlation is 0, then they are completely unrelated. One can go here, one can go there, and so on. Kind of like correlation is, when the correlation is 0, they are said to be uncorrelated or independent of each other. So that's what the correlation sort of gives us. Now, we know this formula is a little bit messy, and it's even worse if you get to 3 stocks or 4 stocks. This variance formula gets very messy if you try to use this. So instead of doing that, we will go to use this guy here, M-mult. The matrix multiplication formula uses essentially linear algebra. It says, and for those of you who were in 4407, you've kind of seen this already. It says, let's name, for instance, okay, as we know in naming, let's name the column where our returns are as R. Let's call it R. So R is the name of that range. Okay? So it's, for instance, for stock A, R would be like, R would be R in January, R in February, or R in 2010, R in 2011, and so on. Okay? That's R. Let's name our weights as, weight is going to be a little bit awkward. Let's name the weights then. And so the weights we'll call, in this case, okay, we'll just call it this. Weight 1A and weight 1. So this will be our weights, this guy. Yeah? And the weights. And so with that, then let's we have one more thing here. Let's also name this C as our covariance matrix. And our covariance matrix takes this covariance here and puts it kind of in a matrix form. Do we have it anywhere here? No. So we're going to have to create that in just a moment. We'll have to create a covariance matrix. Okay? And if you do that, then we can, instead of using this formula here, we can use the M-mult to find our expected return. And it's simply then this M-mult. Or we can find our standard deviation or variance of the times. It's simply this. So our expected return then is going to be equal to the weight of R, this times R. Normally, I'll put this here. And our covariance matrix is covariance of A, covariance of A, covariance of B, covariance of B. So that's our covariance matrix. And so our variance then C. So once you've named the ranges and so on, or once you've used the ranges, you can simply use these simple formulas then, where when you're doing this times this, you actually have to use matrix multiplication and not the ordinary multiplication, which is the times. And so the matrix multiplication function is this M mod. Okay? Okay. So shall we do that, Leon? Okay. Let's do that then. So we do need a covariance matrix. Now over here and here, I have used the two formulas. So for the first, on this first level here, I've used essentially the formulas. The formula for expected return here, and I've used the formula for the variance here. Except to get the standard deviation, I think I took the square root. The rest of the way, however, I want to use the M mod. Okay. So I need my covariance matrix. Yeah? So for covariance, we'll put A here and B. And we can put A here and B. And so this will be our covariance matrix. Let's bring it down here. Our covariance matrix. So covariance S, and we want to take, we're saying A and A. Okay. Down here, we'll do our covariance S between A and B. Down here, up here, our covariance between B and A. And here, our covariance between B and B. So we have our covariance matrix here. One thing to note, of course, is that the covariance of A and A is actually going to be equal to the variance of A. So if you check, for instance, and you just simply do this standard deviation squared, okay, you'll get then that these numbers are the same. Okay? This is the variance of A, variance of A. And likewise, the covariance of B and B will be the variance of B. And you can check. Okay. This B squared, just to make sure you've done. Okay, we don't need this, but we just wanted to check. So this is the variance of A, and it matches the covariance of A and A. The variance of B, and it matches that. Okay. Okay, so let's do the matrix multiplication. Yeah. We want to do the we want to start using the M mult here. So we want to start using this. Because it will make the formula easier. We're going to jump from 2 stocks straight to 4, a portfolio of 4. And with a portfolio of 4, this becomes quite large. Okay? You have 4 stocks here, and you end up having a situation where you have 4 combination 2 is 6, so you have 10 terms, okay? Which is quite a lot. Okay, so let's put our weights. So this is 90% here, and so we'll do equal 1 minus this. So we know whatever this is, that has to be the reverse. That is, we know the following, of course. Weight of A plus the weight of B equals 1. Do you agree with this, Simone? Logically, what does this mean? Just conceptually. When we say this plus this is 1. Equals 1. Essentially, it means you've invested everything. There's nothing on the side. You have $5,000, and half is in A, half is in B. There's nothing left over. So it's you're so-called fully invested. Okay, so we'll drag this guy down to here, and that's fine. Okay. All right, Takashi. Now we know our weights. Weight of A and weight of B are here. Okay. However, instead of it being in a column form, we have put it in the form of a row. So we'll just have to change these slightly. That is, we won't need the transpose. The transpose takes this column. That is, W transpose is equal to, it takes the column here, and changes it into a row. Right? It's already in the row, so we don't need the transpose. So we actually can use this directly here, but we also have to switch this around. We have to switch the transpose over there. Right? Fair enough? Okay. So we'll sort of do that. So let's do the first one here for our portfolio expected return. We'll say it's equal to these guys, and we want that to change. So this is our weight, where our weights are. And we want to multiply that with our returns. And our returns then are also here. Okay? And this is our, oops. We want to multiply. Now, we're doing the M mult function. So we need to put the M mult in. Okay. And the M mult multiplies this by our expected returns. Once again, our expected returns are not in a column, they're this. So we're actually going to now so we're going to take this row and make it a column by doing the transpose. And the transpose, and this is where our expected returns are. Okay. We don't want this to change, so absolute reference that guy. And we're kind of good. If we press enter, we'll still get a mistake here. Because the M mult, and this is what it says here, it's important. When you're using the M mult function, instead of pressing enter, you have to press Shift, Control, Enter. Okay? So we'll go back to here and we'll press Shift, Control, Enter. Now it gives us our 10%. We'll have it go out 2 decimal places and we're sort of good. Okay. I believe we can drag this down. Now, if we drag it down, note it's taking this weight and that return. When you drag it down, it takes this weight, but it still uses the return. It takes that weight, still uses the return. So even when we go down to here, we can see it's using this weight, but still using the expected returns. Yep. So we referenced everything properly, and that's good. So are we good? Truly? Yours is not working. Did you press Shift Control? No, for you. Bring control is command.
No.
This is not. What is that? You're going to have me get a pair of those soon. So, Levi, is it working for you? Is it working for you? Yeah. Okay. Okay, so that's good. Now we get to this guy here, and we're saying that we're going to use our variance covariance matrix. So here we're actually going to do this WC just because of weight, okay? Because instead of a column, we already have it in the room. So we need 2 M modes because M mode only multiplies 2 things together. So in order to multiply them, this guy here, WCW transport, we'll have to use M mode first with this, and then we'll have to use another M mode with that. So we'll do this, then we'll take this times this. So we'll start with M mode. And we have our weights. I'm not going to put the first set of brackets anymore. We actually don't need those guys. So that, and our variance covariance matrix, which is here. Okay. We'll absolute reference those guys because we don't want that to shift. That's fine. That guy is good. And then we'll take all of that. So we've done this first part. Now we'll put another M mode around that and multiply that with the weights, but we need the transpose now. Okay. Transpose of this. And that's kind of good. This is not quite, these 2 things are not, they're not percentages, so I don't want them to show up as what they're not. So it's the standard deviation of that. Okay, that's the percentage. So this is a percentage here, and I think that's good because we've taken the square root. You can see that we've already taken the square root of the variance. So this is a percentage. So in order to get the standard deviation, when we have this, we'll just need to take the square root of that. Okay? So let me put the formula up again so you can take a look at it and see if it excites you. You know, what do you think? Exciting? No? Julie? Colton? Colton says it excites him. He doesn't look excited, but he's processing this stuff internally. Okay? It really is all charged up. This here. So we took this here as our weights and our covariance matrix. When we move to the 4-stock portfolio, it might be to our advantage to actually name this stuff. Okay? But before we name it, we'll see what happens when it's 4 stocks and you want to start referencing. Because building a covariance matrix when it's 4 stocks and so on is a little bit problematic, trying to do covariance this and covariance that. So it's a good idea then to have a simple way to reference. Okay. Oh no, I haven't done the square root yet. Right. Do the square root?
I just did.
So you got 0.892?
0.892. Which one?
For the 90%, 10% weights.
After square root.
No, it was for
Your lights go down.
Let's see what weight you use. No, I'm not sure. That's amazing. Yeah. So keep. There must be something there that's not. Okay, I'm not sure. Somehow we have the same formula, same numbers, but it's calculating everything differently. It's one of these weird things. The laws of mathematics are just different in this space.
Maybe the matrix.
No, we checked his variance covariance matrix. It's the same as this. At least it looks the same. Is it the same way out to all these decimal places? It is? It should be. I mean,
Yeah.
it's simple.
Well, because it'll take it across what it shows. It'll take the same number.
I don't know. I mean, I imagine. Well, let me take it from saying I can't see at first go. So I just put the square root in there, and we put the square root there, and it's fine. So now we can just copy this. And these, of course, are all in percent terms, so we're good to go here. Yeah. So, of course, we can plot this and see what it looks like. Okay. So if we plot this, we can insert then, this would be an XY chart, and we probably will go with this guy here. Oh. This looks a little weird.
Carlton, can you just go to the 9, or is it 7.44? Just so I can see the formula? Yeah. Like, is the square root in front of it?
So all I did was, I just added the square root before. So I just did square root, put everything into square root. Variance, covariance matrix. Okay, so all he had a negative. One little thing.
Yeah, it could work. We have to. There's nothing there. This is okay. So what we want to plot essentially is we want to plot our standard deviation and our expectation here. This is called then the mean variance for the risk return plot. Okay? And with the XY plot, I think it typically takes this as Y and this is X, but somehow it's not sort of really doing that. I'm not sure what's going on. So I did plot that here, and I did this, and that's looking strange. 10%. And 14. So it's switched it around. Select data. Somehow it has a portfolio standard deviation. So let's just switch them around, okay? Oh, that's no good. Okay, it is an XY plot, so it's taking this. So I'm taking this as the X and this as the Y. So. So maybe if we switch them around. So let's move. Moving this back. Let's move it over here. Move this guy here and move this guy back. Okay, that'll work. Okay.
What did you do?
Oh?
What did you do?
I just switched you.
Just confused. So under select data?
Yeah, so you can do it with the select data thing as well. So let's try it with the select data. So with the select data here, we can just change what the series X is and what the series Y. So change this to D and change this to C. Or you can click and just change the change this guy to C and C. And the series name. Yeah.
Oh,
So that's sort of what it looks like. Yeah. So you highlighted that with your XY chart. And then we select data and switch it over. Because right now it has the deviation. Initially when we did it, it had this as X and this as Y. We want this to be Y and this to be X. And you can go about naming the cells. But if you've taken portfolio theory in 4407, the shape of this will start to look a little bit similar, right? That is this sort of shape you see right there. So this is for the two-stock portfolio, and it's fairly straightforward. We want to see what's going on for a four-stock portfolio. Okay. Okay. So for the four-stock portfolio, I'll allow you to do the expected returns and standard deviations, and you can do that all on your own, and that's fine. But for the covariance functions here, things are a little bit tricky. Okay. If you don't want to keep writing covariances all over the place, okay? If you want to put a formula in here that will be able to cut and paste using all this information here, how do you do that? That is, you want to essentially take this, for the first cell, you want to take, and that's sort of where we might end the class. For the first cell, the function we want to use then is this guy, the indirect function. And I think it says so here, the indirect function. So we want to use that, okay? Indirect. And we want to take, for the first cell, we want to take the covariance between B2 to B6. So B2 to B6. And the covariance B2 to B6. But we want to be able to change this so it goes from B2 to B6, and when you copy it this way, it'll take this B2 to B6 is fine, but it'll start to change this to C2 to C6, right? D2 to D6 and so on. And when you copy it down this way, okay, it'll keep essentially B2 to B6 here, but it'll change this B3, okay? Sorry, it'll change here, okay, C or C2 to C6 and so on. So we'll need a little bit of help because we didn't name this yet. It actually is easier if you name it, but we'll do it the hard way first, okay, and not worry about naming. So let's use the indirect function. I'm going to shift everything down a bit, Control X, just so, and we'll just put B, C, D, and E, okay? And we'll put that here, B, C, D, and E, okay? I guess we should have used capitals, but that's fine.
So instead of using B2 to B6, I wanted to pick up this B and that B. So I'm going to say essentially the covariance between, and so now I want to take that B. To get this B from this cell here, okay, yeah, I essentially will use indirect function, indirect. What indirect does is it takes whatever is in a cell and converts it to a string. It takes a cell and converts it to a string. So it'll take that B and convert it to a string. So we'll take indirect what's in that cell, and that cell is H3. So indirect H3. Okay. So it's going to convert it now from B to C to D when we copy that. And we'll have to, I guess, add on, right? So let's see what happens first if we do this. Let's see if we do this. Let's see here if we put in indirect. And we'll take this guy here, reference text, H3. And guess what?
Can you just use absolute reference for the covariant function and just put it on like the column but not the row instead of using indirect?
You're saying,
Like
yeah. So you could do that as well. So you could put absolute references here, but
You'd have to flip it, you'd have to change like
Yeah.
almost every one of them.
so you could do that. The reason why I'm doing this, let's see, I'm trying to get the sense here. So the reason why I'm doing it this way is, if you do it this way, okay, it turns out later on it will allow you to have this this row that's here, or this column that's here, change in length. So once you've done your variance covariance matrix and you've done it using the indirect function, okay, if you add a new year to this, it actually will update the variance covariance matrix. Okay, so it'll start updating. So, okay, let me take a look here and see.
You need the ampersand in your indirect function. Tab between.
Yeah, I think I needed to put the ampersand actually I think should have been outside. Where are we here? No, that's not working here. Okay, we're out of time again, but yeah. So we'll finish up with this and then go into the three-state GDM on Wednesday. Let me stop recording here and we're sort of up.